These are the notes for Algebra 2, Section 6.4. We're talking about inverse functions, and this is the first of two parts where we look at inverse functions. To begin with, we're going to look at some vocabulary. Now, we know from lessons at the beginning of the year that a relation is a pairing of input values and output values. Okay, that's a relation. And it doesn't matter how we get the outputs. All right. We could just say, all right, well, if you put a random input in, you get a random output back. You put 1 in, you get 2 back. You put 3 in, you get 4 back. It doesn't matter. Whatever you plug in, you have to be able to get something back. That would be a relation. An inverse relation exchanges or interchanges the inputs and outputs of the original. So what used to be the output for the original relation is now the input for the inverse relation, so on and so forth. So, for instance, if I had an input of 1 and 2 giving me an output of 2 and 4, then the inverse relation would be an input of 2 and 4 becoming an output of 1 and 2. So our numbers literally just flip around. What was in is now out. What was out is now in. If both the original and inverse functions or relations are functions, that is, they qualify the requirements for being a function, right? They've passed the horizontal line test. They don't repeat inputs, those kinds of things. Then the two functions are inverse functions. Now that's what we're really going to be concerned with, are inverse functions as opposed to inverse relations. But they kind of go together. Alright, so for instance, we can see here, just as an example, I have my original relation, and it's just a bunch of numbers, right? Inputs are my x values, 0, 1, 2, 3, and 4. My outputs, my y values, are 6, 4, 2, 0, and negative 2. And they're graphed here in blue. So those are my original relation as a graph. You can see my inverse relation. All I did was change the x values and the y values. So what used to be the y values in the original became the x values in the inverse. What used to be the x values in the original became the y values in the inverse. I literally just swapped x and y. I get a different set of points in that case. And what I'd like you to notice is that these points are these two relations are reflections of each other along the line y equals x. Right? This is the line y equals x. And all of my points are reflected from the original to the inverse on this line. So I have this point here in my original relation is reflected to this point here in my inverse relation. You can see they're reflected along this line. Ditto with this point here in my original is reflected to this point in my inverse. We could keep going. This point in my original reflected to this point in my inverse. This point in my original to this point in my inverse. So my inverse and my original have this reflection going on. Now that's all well and good, but we need to know how we're going to use this. And the way we're going to use this is by taking a function or a relation and finding the inverse. And it's really not all that complicated because it's mostly just solving equations. And we've been solving equations forever. Let's see how this works. Now we want to find an equation for the inverse of the relation y equals 7x minus 4. Right? So we want the inverse of this relation. It's really very simple. We know that the inverse is when we exchange x and y. So the first thing we want to do is exchange x and y. We're just going to flip it around. This becomes, instead of y equals 7x minus 4, x equals 7y minus 4. So you can see what happened. My y's and x switched places. That's all that happened. Now that I've done that, I want to solve for y. That's my next step. I want to solve for y. So I want to switch x and y. Then I want to solve for y. Those are my steps. Switch x and y, solve for y. To solve for y here, I start by adding 4. Now this is just solving equations, so we don't have to worry too much about this. I have 7y equals x plus 4. So I divide by 7. And I get y equals, I'm going to flip it around here, y equals 1 over 7x. I'll make that look a little bit nicer here. Y equals 1/7 x. Right? X divided by 7 is 1/7 x. Plus 4 over 7. This is my inverse relation. Y equals 1 over 7x plus 4 over 7. Done. Let's try it with a slightly different equation. I want to find the inverse of y equals negative 3x plus 1. Again, I start by switching x and y. So I'll go, y will move over to where x is, x will move over to where y is, and give me x equals negative 3y plus 1. From here, I just want to solve for y. Alright, so to solve for y, I start by subtracting 1, and I get x minus 1 equals negative 3y. This probably should start looking kind of familiar. Divide by negative 3, I get y equals negative 1/3 x. X divided by negative 3 is negative 1/3 x plus 1/3. Negative 1 divided by negative 3 is positive 1/3. And that is my inverse. Again, just solving equations. Same as usual. We might be asked to verify that two equations are inverses of each other. Now what that means is we can tell if two functions, in this case f and g, are inverses if f of g of x equals x and g of f of x equals x. Now if you're not entirely sure what that means, I'm going to put it in real big bold letters at the bottom. Basically, plug the functions into each other you should get x. And we'll see how that works. We're going to plug the functions into each other. We should get x back. Now let's look at how this works. I want to verify that f of x equals 7x minus 4, and the inverse, notice that the inverse here is f to the negative first. That negative first doesn't mean the negative first power. It means the inverse of f of x. That f of x and its inverse are, in fact, inverses. So here's what we want to do. We want to start by plugging this equation into that equation and seeing what we get. We should get x. So we have f of 1 over 7x plus 4 over 7. Now, that means that we're going to replace x with 1 over 7x plus 4 over 7. So let's do that. We've got y, or we don't even need to worry about that. We could put y equals, but it's a waste of my time, so I'm not going to worry about it. Instead, I'm going to start with 7x, but of course x is 1 over 7x plus 4 over 7 minus 4. So notice I've taken x, this whole thing here, and I've plugged it in for x. That's what I do. Again, you plug the functions into each other. And of course, theoretically, if these are in fact inverses, this should equal x. So let's see what happens. Now we have 7 times all this stuff. We have to distribute 7. So 7 times 1/7 x is x. 7 times 1/7 x is x. 7 times 4 over 7 is 4. Right? 7 times 4 is 28. 28 divided by 7 is 4. And that's minus 4. Now you can already see, or at least I hope you can already see, that we have 4 minus 4 here. 4 minus 4 cancels out, and we're left with x. Like I said, we plug one function into the other function, we should get x. It worked on this side, we have to make sure it works on the other side too. So we're going to swap it around. On this side, we plugged the inverse into the original. Now we're going to plug the original into the inverse. So let's do that. Our inverse is 1 over 7x, but of course now x equals 7x minus 4. We plug the original into the inverse. And we're going to see what happens. Again, we have to distribute. We have 1/7 times 7x. 1/7 times 7 is 1, so we get 1x, which is just x. 1/7 times negative 4 is negative 4 over 7. Plus 4 over 7 that's sitting out here on the side. Again, this may look a little different than the solving equations we're used to, but it is still just solving equations. Now you can see here I have negative 4 over 7 plus 4 over 7, which cancels out, leaving me with x. Both of these equal x. These two functions are, in fact, inverses.